Alright, so what's up guys? Today we're going to be dealing with two column proofs. So our given L is parallel to M. So for our proof, L is parallel to M. Here we're going to write statements. And then here we're going to write reasons. So our first statement is always our given. L is parallel to M. You can see L is parallel to M. Reason is given, right? We already know that. L is parallel to M. So for first, how do we? So for first of all, we have to connect it to without using alternate exterior, because you could do 2 and 7 alternate exterior, and we're not gonna do that today. So first of all, we could do 2 is congruent to M angle 6, right? I forgot to write M angle, but you get it. 3, corresponding, right? Corresponding angles. So for our third, we already know that 2 is congruent to 6. If you saw the last two videos, vertical angles theorem, 2 and 6 and 7. So 6 is congruent to 7. 6 is congruent to 7, right? We already know that because of our vertical angles theorem. Angle theorem. Vertical angles theorem, right? Vertical angles theorem. So for a fourth, right? And if you saw the last video as well, we went over transitive property. If 2 is congruent to M to 6 and 6 is congruent to 7, we could do that 2 is congruent to 7, and we prove our statement 2 is congruent to 7, right? We could do that. Oh, this is supposed to be 1, this is supposed to be 2, it's supposed to be 3, right? So we could do transitive property. Transitive property. I wrote it wrong, whatever. So instead of doing that, why not just use substitution? Much easier. We already knew 2 is equal to 6 and 6 is equal to 7. So why not just replace the 2 for the 6? So 2 is equal to 7. So you could do transitive property just in this scenario, or substitution, right? Because all transitive are substitution, but not all substitutions are transitive. Do you get it? It's not reversible. It's not, you can't really flip it. You can't flip it. You can't make it a circle, For our second example, yeah, the first time I recorded this, it failed to record, so I have to do it right now. Alright, so I cannot stress this enough. Your first statement should always be the given. So L is parallel to M. Alright? 1. The reason behind that is that it's the given. It's the given, so you don't gotta explain that. So 2. So we see here that 1 and 5 are corresponding angles. So we could put M angle 1 is congruent to M angle 5. So 2 is corresponding angles. The astute will notice that, that first of all, I didn't write it down, the numbers, and that 4 and 5 are just, the astute will notice that the astute will notice that these are consecutive, right? But we're trying to prove that we could easily go from the given to consecutive angles, right? Easy, but we don't want to do that. We want to prove it. We don't want to just like, I get, yeah, it's whatever. But we could use that these are a linear pair. 1 and 4. You see one angle 1 and 4, angle 1 and 4 are a linear pair. So we could say that, hey, m angle 1 plus m angle 4 equals 180. Our reasoning behind that is that they're linear pair. Linear pair equal 180. See, and then reasoning 4. You see here, m angle 1 plus m angle 4 is 180. How is that? How does that matter? If we're trying to prove that m angle 4 and m angle 5 equal 180. But you see here, it's not m angle 1. M angle 1 is congruent or equal to m angle 5. You see there? M angle 4 plus m angle 5 equals 180. We could just substitute. We could just substitute. Easy, nice. Then substitution. Substitution. I don't know how to write it, alright? I only knew how to do the math, the proofs, right? Awesome. Oh. Awesome. So this one is super tricky, right? So, alright. It looks easy, but it's kind of tricky, right? So the first one is obviously the given, right? We could just, so the first one is always the given. The first one is always a given. Second one, how is angle 1 and angle 2 congruent? Let's see. Angle 1 and angle 2. So when you're working with these, right? It's like two parallel lines cut by two transversals. How are we gonna know that? So what I like to do, grab another highlight color, right? You see here, boom, boom. This is angle 1. We could, and this is angle 1. This is angle 2. We just extend these lines. If you see here, it's cut out. 1 and 2 are 1 and 2 are corresponding angles. You could use the corresponding angles theorem for that one. Corresponding angles theorem. So let's write that down. Alright. 1 and 3 are congruent. This is what the statement is saying. 1 and 3 are congruent. How do we know that? How do we know that 1 and 3 are congruent? You see here, 1 and 3 are congruent. So that step was easy because it's the given, right? It's the given. It's the given, whatever. So now, statement 4 is telling you that 2 is congruent to 3. How do we know that, right? So 1 is congruent to 2. 1 is equal to 2. The angle of 1 is equal to the angle of 2. And then angle of 1 is equal to the angle of 3. We know that it's the given. It's the given, right? It's the given. It's the given. And so angle 2 is equal to the angle of 3. Substitution. Because if 1 is equal to 2 and 1 is equal to 3, boop, boop, 2 is equal to 3. So that's substitution. You could also do transitive property. Either or, but I like to use substitution. Keeps it nice and simple. So R is equal to P. R is parallel to P. So this is angle 2, this is angle 3. And if they're congruent, that must mean that they're parallel. You could also know this because look, angle 2 and angle 3 alternate exterior property. Don't get confused because it says R is parallel to P, right? You think, how do I know that? But if you see here, Since we 2 is 3, oh, this is the converse. Because we don't know if it's parallel or not. The converse tells us that, hey, converse alternate exterior property tells us that, hey, if these two sides are congruent, then these two are parallel. So now we could tell that dp is equal to parallel to r, right? How? But look, something something I didn't explain. So here it's angle 2, and this is angle 3. Angle 2 and 3 is the same as P and R, it's just different names for them. Angle 2 is equal to angle 3. See, it's on this side, this one is on this side, the P side, and this one is the R side. So we just proved that R is parallel to P from that L is parallel to M, and that angle of 1 is congruent to the angle of 3. Awesome.